Okay, hello. So today I want to talk about REST. It's probably one of the most misunderstood subjects in computing. Basically, everything that says we are RESTful isn't. So I want to take some time to first explain what is REST, what is it exactly, and then show some work I've been doing about REST, ultimately leading to a REST client that can handle any kind of RESTful service. Unfortunately, I didn't go that far, so perhaps there will be a second talk for more advanced subjects, but I think there's still a lot of content to cover today. So REST is very good. You lie in bed and you simply relax. That's amazing. REST, of course, is not just that, it's also an architecture. And that architecture makes working with web services a lot easier. So we will see that. So the picture is little, but yeah. So explaining REST is part of my job. It's the family business. REST is a big part of the web, so I have to provide code for it as part of Cowboy, and I also have to explain it. So this is what I've worked on the past 2 or 3 months. And I also want to open your mind with this talk because the capabilities that are made available by using REST are simply too good to be ignored. So REST defines a set of constraints that you must follow to implement the REST architecture. So first, a REST architecture is client-server. So most of the constraints you don't actually have to worry about when you create a REST API because they are already handled by HTTP. But we will still explain them to make sure that we understand what we are talking about. So by separating the client and the server, we separate the concerns. The client cares about showing the data to the user or processing it automatically. And the server cares about storing the data, providing it to the user in the appropriate format, efficiently, and so on. And if these things are separate, then we can make them evolve independently. REST is stateless, so messages always contain everything. You don't keep state on the server. You don't keep state anywhere other than the client. The client keeps everything and sends everything it needs to send to process the request every time. That includes authentication, but so there's something, some people that say you can't use cookies if you use REST. That's not exactly true. Cookies can be used as token-based authentication, but that's all you can use them for. You can't have session-based cookies or anything like this. The client, of course, keeps all the state. There are different ways depending on the client you have. Browsers used to have only cookies, but now we have client-side storage and so on. The third constraint is that the data that is sent must be cacheable. So anything that is sent by the server. All the responses, all the resources that are sent may be cached. And all the resources we can know that this resource can be cached or not. This is very important. This isn't always explicit. For example, with HTTP, you have some implicit rules about this, but you can always say, I can cache this or not. And it's always the server that controls this mechanism. The fourth rule is the most interesting to us because this is pretty much what we will do when we implement a REST API or a REST client. So REST defines a uniform interface. We have a common protocol, a common set of rules to speak to different components. So if I speak to a server, I use the same interface I use with a proxy or a gateway or anything. It makes it easy to understand the interactions because we only have one thing to learn. So all the way from the client to the server, we will have always, when using HTTP, for example, we will always have the same rules. And, well, it's more complex than that, so let's move on for now. REST is layered. That means that we have, of course, a client and server, but we may have any number of components in between. Proxies are the most common example of that, but we may have a server that itself speaks using REST to different parts of the system. And one part of the system only knows about the direct, the component it speaks directly to. So if I speak to a server through a proxy, I'm not aware about the actual server architecture. It could be one server behind, or it could be 10 servers. So I have no way to know this, and I don't need to know this. Similarly, when a client speaks to us, we have no way of knowing if it went through a proxy or not. Well, there are ways, but we can't rely on them. And finally, the last one is code on demand. So this one is optional. This is pretty much what browsers do, well, what servers do when they send some JavaScript along an HTML file to provide additional functionality. It's optional in the sense that you can't rely on the client having support for the code that you are going to send. So if you send some data and some code to process it, you have to make sure that the data contains everything. You have to make sure that the code is really about extending the functionality and not about actually accessing the data. So the uniform interface defines 4 additional set of constraints. And this is where resources, resource identifiers, representations, and so on are defined. So this is the most important part for us who are going to write APIs or clients. So what is a resource? It's an abstract concept, and pretty much everything that you can give a name to is a resource. So that means, for example, a list of users can be a resource, one user can be a resource, and even you can be a resource. A person can be a resource. It's really abstract. Of course, you won't be sent through HTTP, but a representation of you may be. So we will come to that. A resource has an identifier. So this is the URI. This is pretty much the name of the resource. This URI, I didn't Okay, so this URI is points to a resource. But if we have different URIs pointing to the same data, it is still two different resources. Yeah, and I also point out that typically we will have two kinds of resources. Resources that simply point to a set of different resources, and then these resources. For example, a list of users would be called a collection, and one user would be simply a normal resource. Representation. So this is what is actually sent to the client and processed. A representation is simply a sequence of bytes and some metadata. It doesn't matter for REST. It doesn't matter what exactly that sequence of bytes is, with one exceptions that we'll cover. There is three kinds of metadata. One covers the representation, for example, when it was last modified, a checksum, things like that. And of course, the most important being the media type, but we will come back to it. The second is about the resource. We could have links to related resources, for example, a source for an article or things like that. And it also has information about the different representations we can receive the resource in. And finally, control data is more about parameterizing requests. For example, if I request a resource, but I only want it if it was modified since yesterday, that's control data. So this part is probably the most important part, and this is one that is typically misunderstood. In REST, all messages must contain everything that you need to be able to decipher them. So if you have a REST API that has some documentation telling you if you query this URI, you will get data using sent as JSON, for example, using this particular structure, and it sends you JSON, then this isn't a REST API. It's missing something in the message. We know we have JSON, but we can't do anything with the data because the data is actually described separately from the service. We need to have a specific media type to properly describe our data. Of course, this media type may be based on JSON, but if we have a user with a particular structure, then we need to define a media type for users. And that's very important because then everything in the REST service is properly described. Media types, media types do not need to be standard. They don't need to be registered. I think it's at INA. You can create your own media types without any problem. What only matters to be RESTful is that both the server and client agree on what this media type means. And another part that is often missed is that REST is driven by hypertext. So that's links. That's the same kind of links that you have in HTML. So if you send some JSON, you don't have links in JSON. So you can't be RESTful by sending some JSON. If you create a media type on top of JSON, you may be able to. But you are still going to miss a little thing that I forgot to mention. Hyperlinks typically, well, to be able to process data, you need two things. You need the link to be able to get the different resources, and you need to know the relationship of the current resource with the link, because then you can figure out what exactly I'm linking to. Otherwise, it's just a random link, and you can only write a crawler, and that's not very useful unless you are a search engine or something. So we need to provide these two things. And a client only requires to be able to work an entry point. So for example, 99.eu/, and it needs to understand the media types that will be used by the service. And everything else the client can discover at runtime. So this is pretty much REST. I hope I was clear enough. But yeah, so when I reached this point in my understanding, basically these two parts are very hard to do with current formats. So I still looked. What media type should I use for my services? And sorry, yeah, I already. So I looked at JSON, and JSON is terrible. It's the worst format. No, not the worst. I cover another one later, but it's very bad. Well, it doesn't have links or link relations, so I can't really link different resources, so it doesn't help me there. It can't deal with binary data, and it actually has many different issues due to how JSON is UTF-8. So you have some problems with different types of data. I will come back to not very good with the map data type because that's, I will explain later. And yeah, it's very hard to parse JSON. It's a text format. It's good for us people, but it's not very good for computers because I actually have, had one client who was using JSON for a chat server, and JSON was using basically half of the processing power. And then I moved JSON to message pack, which is pretty much JSON, but binary, and I didn't have any process being used anymore. So JSON is terrible. Stop using it, please. I actually believe that part of global warming is caused by JSON. But yeah, message pack is a little better, but it still doesn't have links or link relations, and it doesn't have other things I want, like big nums or decimals. By the way, decimals in JSON are terrible because if you send a number, JSON basically has only a float, and that's not a very good precision. Yeah. Why not HTML? Well, HTML is a good format for REST, but it's not very good for sending data, raw data. It's good for sending documents with structured data in a way that your user will be able to read. But it's not really meant for automated processing. If I send some numbers, in HTML, numbers are just text, so I can't do much with that. So yeah, HTML is good, but not for what we want. XML, well, it's a little like HTML, except XML is better for what we want to do because we can describe types and so on, but we still can't send, well, easily send binary data, and XML is very slow. It's probably worse than JSON, so XML is also responsible for global warming. And yeah, we are doomed. So what are we going to do? I have no idea. So I actually spent a lot of time thinking on this, and this is the main point of the talk today. So I created a format, a binary format. And I made it have everything I wanted, which is hyperlinks, yeah. It's in binary, and we always specify the size of things. So the parsing is very easy. If we don't understand something, we can look at the size and simply skip it. It's the encoding, the data, once it's encoded, is very, very small, and I will explain why. And it's even more useful for streams, but we will see. It has, I think, a good type coverage, but that is not for me to say. I don't want a null value. For example, message pack as a null value. I don't think that's a good idea. If you have a null, you simply don't send anything. And hopefully, it will be fully specified. So there's two media types for it. It's very simple. There's the bed one. Oh yeah, by the way, bed means binary electronic data, but it's mostly for the pun. So yeah, we have the normal message, which is just one message, and then the stream media type, which is a series of messages, one after another. So it's not very complicated. But these are simply the standard types. You must always, when you create a REST service, make your own media types on top of it. You can, of course, send your own media type, for example, my users, and also the bed media type, and then the client can choose. You can also send JSON or any format you want. Just provide a complete description inside one media type at least, so that we can write clients to process the data automatically. Okay. So now I'm going to list all the types in the format. So the first is links. So I simply have two kinds of links because a link relation is nice, but we don't always have it. So I allow providing links without a relation. But it's better if you can provide a relation, for example, source or a link to a copyright document or license or things like that. You have relations that are defined that allow you to tag. It's kind of a tag for the link. And it helps when writing clients for automated processing. So there are a few which are already defined. Well, there is an RFC for it, and there is also some others that have been added for HTML5. So look in there. There are some that you can already use. And links are constructed with, well, all the values here have basically one kind of opcode before the actual value. And links are simply a type that contains other types, and it contains a string. So we will see what that means in a bit. And the relation is a symbol. So we will see again very soon. It's really important that you use fully qualified links when you send them, because the only moment a client should actually build a URL is when it, for example, when I do a put to save some data, so to save a resource on the server, I may provide the full URL of the resulting resource instead of creating it dynamically. So this is one case where building dynamically the URL is fine. This is one of the only cases. When the server sends the link, you need to provide the full link. You don't want the user to reconstruct based on a user ID or something like that. And that's true not only with this, but also with HTML, JSON, or anything. So the second type is symbols. And as you can see, it must be a very complicated type because we have 9 slides. So I looked, when thinking about this format, I looked at typical use of JSON in web services. And this one is actually very small. There are some services that simply send 1 megabyte of JSON with the same thing we see here over and over and over. Because they have not only one user, they have 100 users instead. And they have tons of information that is shared between the different users. They all have an age, they all have phone numbers, and so on. So here you can see, even in this small example, that there is some redundancy. In the phone numbers, we have a key that is named type, and we have a key that is named number. And by seeing this, I thought, why are we sending this string over and over and over? This takes a very large number, a very large size over what we are going to send to the user. And then I remembered that I was an Erlang developer. And in Erlang, we have something that are called atoms. And atoms are basically, we have some symbol, some name, for example, blue. And internally, it's actually a number. And when we send this atom to another process, we don't send a string. There is no string comparison or anything. It's number. So why not do this with this format? Because we are going to send many keys the same over and over. And this is even more true if we are streaming. If, for example, I have a stream for a chat service, it's always going to be chat message from, date, and so on. So why repeat this over and over? So I'm going to keep a dictionary of words that are of symbols that are sent. And every time I send a new symbol, I will give it a number. I start with false and true, which are quite used already. And we can, of course, add some more predefined if we want. But, let me show you an example. So this is one message. This is actually the example that message pack shows to demonstrate how little the data becomes when using message pack as opposed to JSON. So they win exactly 9 bytes. Whoa! So this is a very small JSON. More real-world examples would actually be much larger, and message pack would be much more efficient. But the bed format is actually exactly the same as message pack for the first time we send this message. But then we are going to send another message with exactly the same structure, a key with compact and a key with schema. And then we only send 5 bytes because we don't have to send the key compact and we don't have to send the key schema. and they all become exactly 1 byte. And then we send 5 bytes for everything following instead of 27 or 18. So I think that's pretty cool. And of course, we sacrifice a little CPU, so we probably won't be responsible for global warming, but we will contribute. But we save in the bandwidth that we need to send all our data to users. We can save actually a whole lot. And the larger the message, the more we will gain from this. And of course, even if we have to do some lookup, it's not that bad because we will only have a fixed number of symbols defined. If I send a list of users, then I will have maybe up to 100 or 200 different keys in my maps, and so that will be just a couple hundred symbols. And so this isn't performing a lookup like this is actually very fast. And we have all this without any compression, without defining any schema. The user doesn't have to define a schema. We just have to call the encode function, and we benefit from all of this. Of course, I'm not covering it here, but the input needs to be in a specific format. But we can make some assumptions about symbols. For example, if we have a lot of maps with string keys, we can assume they will all be symbols. And yeah, so it's encoded like this. For the first 32 symbols, it always costs exactly 1 byte. So if you have symbols that are repeated very often, you can define them first or define them in your own media type, and this will always cost 1 byte. And then, depending on the number of symbols we have, the symbols after the 32 first will cost 2 or 3 bytes. So 3 bytes allows us to have symbols, well, up to 2 million symbols, so that should be plenty. So we have a few other boring types, like a binary. We have strings, which must be UTF-8. So why UTF-8? Because that's pretty much what everything on the web uses today. So it's simply easier to go this way. It should be validated when we decode it, but this is actually quite expensive, so I recommend that to provide an option to disable it. And strings are sent as with the length first. We don't want character-terminated strings, like null-terminated strings, because these, you can't know how much you have to allocate first. You can't know the size. For all you know, the string will be 10 megabytes, so you may not want to actually read it. So yeah. Then we have another type that is a bit unusual, the date type. So this one is not so much because we need it, but because it actually makes things a lot easier. Many things in web services and in streams use a date. And there are maybe 10, maybe 20 different ways to represent a date. And converting between those and making sure that they follow DST properly and things like that is actually very hard. So instead, by using this particular date format, we make sure that there isn't any ways to introduce bugs simply by mishandling dates. So in essence, it's still more or less a string, except we know it's a date. Then we have, of course, integers. So I want all the way to big nums. The implementation of big nums in Erlang doesn't allow for an infinite number, but it's still, I think it's 255 power 255. So that's a huge number. And we have, for the the smaller integers, minus 32 to 31, it will take only 1 byte, because the integer is actually part of the opcode that we send. We have floating points, so I'm not covering them in details because floating points are complicated and I haven't finished this part yet. But I want 2 of them. I want the double format, which is pretty much what you have in C code, for example. And then I want the decimal format, which is actually precise. And these are well defined. We just have to properly add them to the spec. And then we have actually 3 different ways to provide structure. We have maps, which you pretty much know what they are. For small maps, it will take only 1 byte followed by the actual map content. So it's not too bad. And something that we have to make a choice when the map is sent with duplicates. It shouldn't happen, but not all code is perfect, and so we have to define what happens. Here I chose to keep the last k value simply because actually checking if it exists might be a little too expensive. So it's just a choice. It could be, we could fail, but I don't think it's a very good idea. Then we have arrays, which are lists of known lengths. So pretty much just an ordered list of values. And then we have a special type list, which allow for creating lists of unknown lengths. So this one doesn't actually have a length. And this one is actually not, well, it cannot be used with the basic types, the xbed and xbed stream. Because to decode a list like this, you probably want to actually stream the list itself. It may be 1 element, or it may be 1 million elements, so it's actually a special case. But we still provide it in the format if needed. The default encoder and decoders will simply skip all the data from lists. So this way we don't have any problem. And then we have 8 different ways to provide extension values. And we can have up to 256 additional types for use in the media types that we will build upon the standard ones. So similarly, the default encoder and decoders simply skip them. They don't know what they are. So bed is, I think, great for REST because we finally have an efficient format with support for links. And it's also great for WebSockets because it simply is very efficient, not only for the size, but also for the processing power we need to encode and decode things. And the bed is comfy, of course. So one question about binary formats is, does it make it harder to actually debug things? Well, it can if your only tool is telnet, but you probably don't use telnet very often to debug things today. So you simply have to add a well-placed call to the decode function, and then you have the data in the representation used by your language. So it's not very complicated. And if you have a large amount of data, if your resource sends 1,000 users, you won't find what you want in it easily anyway. So having it binary is pretty much the same as having it in a large enough JSON. And of course, if you have a web REST service, you can provide different media types, and you can have a human readable media type for debugging if you need to. And finally, the last part is writing the REST client. So unfortunately, I haven't written any code for this part. I have thought about it a lot, but working on the bed format was so interesting that I simply worked on it until yesterday, actually. And so, yeah. But because of all the constraints that are defined in the REST architecture, it's actually not that hard to write a client. I will cover the general idea, and actually I also want to get some feedback on what people use today in their work, so that I can make, hopefully, the appropriate choices. So the goals are to only manipulate resources. We only use URIs for querying them. We don't look into the representation. It doesn't matter if we receive JSON or anything, except in one case, which is actually just below, when we want automatic discovery of service capabilities. That's when we will, of course, need to look at what it's actually sending us. But otherwise, the main function that you will use will take a media type, take the representation, the data, and send it or request it. And we want to provide automatic caching, because that's actually very nice. When I use my browser and I go to GitHub, it doesn't, actually GitHub is not bad. When I go to Twitter, it doesn't take forever to load. It only takes 2 seconds. It's actually forever, but you get my point. It has already a lot of scripts and files that are already loaded. So I want that also in a client that I will be able to use to process data. Because if the data hasn't changed on the server, there's no need to actually request it again. I can simply work with my cache, and that's it. So this should be automated, and this is something that you shouldn't have to worry about. And of course, the caching is URI-based. So when we have a URI, we simply look for this URI in the cache. I will use Gun as the client. So Gun is a client I've been working on for with the Leo FS project. And Gun is meant to be used for querying services. It always stays connected. It tries its best, at least. With HTTP, it always sends an empty line until it gets disconnected, even if it doesn't have anything to do. So it's great for that kind of use. And what do you call a REST-based client, a REST client based on Gun? Well, Gunner, of course. Another thing, so this is actually the part where I stopped and needed feedback. We don't want to hard code URIs, of course. We want the service to tell us what are the URIs to request users or articles or things like that. And we have 2 different ways. We can do it at runtime, but it's not going to be very fast, or we can generate a client based on what the service tells us. we could poke the service by querying all the URIs we find until we have the information we need, but that's not very good. Otherwise, there is, I don't think it's a standard yet, but it's at least a specification which is called RSDL, which describes a REST service. But RSDL is XML, and yeah, I hate XML. And RSDL is actually very, very complete. It describes everything from query strings to the content of the data that it sends and so on. It's so huge that I don't think anyone in their right mind would spend the time to describe their service like this. So perhaps we can work on a kind of subset that allows us to do something similar. Perhaps we can then generate RSDL from it. But that is something that people would be willing to do, because that's the important part, finding common ground between having the perfect thing and the thing people want to use. And so I need feedback on this. How much are you willing to describe your service? And then when we generate an API, it can look like this. We simply need, well, if we have users, users have a different set of URIs. And get all doesn't need to know anything. You simply query the appropriate URI, and it returns the list of users. And if we know if the client and the server agree on a common media type, then we can easily convert this list of users into terms that are used in our language. So that's why we just have a getAll function, and it returns a list of users. Then if we want one user, we need, actually, no, that's okay. No, actually, I got a little confused there. So there's two ways, there's two getAll calls. We want one that actually do the conversion, and we want one that doesn't. And then we have get similarly. We provide the URI, and we get the user. We may want a specific media type for the user, or we may want this client to do everything. And similarly with Spot, we provide the representation, and it sends it, and so on. So we can generate this based on these specifications. But yeah, how far should we go? That's the question. And then cache would be implemented like this. We have a get call that first looks into the cache. Get or getAll would do that. And if it is in the cache and the cache is still valid, then we simply return this. There's no need to query the server. The server is the one that tells us what to cache, how to cache it. For example, you can cache data, and the client may not query the server to know it's updated, or you may want the client to query the server. So there's a few different cache mechanisms, and the server is the one that dictates how it works. So we can rely on it. It's always the server. The client doesn't need to, the user of the client doesn't need to care about this. It will always get the data that the server wants the client to get. And of course, we could go further with RSDL. We could also, for example, when we provide data here, we could validate it. I'm not sure it's worth it. The server is going to validate it anyway, so yeah. I want to know. Tell me how much you would be able to use this. because I have no idea. And it does sound like a lot of things to do on the user part to get too little reward at the end. So that's it. So here are a few helpful links. So the first one, there's actually nothing on it, but I will start with the specification, probably, well, hopefully tomorrow, but we know how conferences go. And Gun, you can find at my GitHub. Gunner, I need your input, and then you have my Twitter and website. So one last comment, I'm still looking for sponsors for my work. I'm trying to spend as much time as possible on it instead of working for a client. So if you are interested in sponsoring me, please come talk to me. Thank you.
Thank you very much, Loïc. That was awesome.